Wednesday already, so there will be no quiz. It'll just be us attempting a question on a regular basis, and I'll throw some ACs at you, and you just basically, if you do your homework, you're gonna be fine, right? If you try these, you're gonna be fine. If you use your class time wisely, you're gonna be fine. If you added all the formulas, you're gonna be fine, right? So that's all I'm gonna say to it. Let's try page 16 here. Calculate the total exposed surface area and the volume. Now we're imagining this is just free floating in space. So even though this view right here may seem like this is touching the ground, we would just assume we want to include everything around it. I will try to be specific. I will try to say, hey, no, don't worry about the bottom of this piece, or I will tell you that. And what you've seen in my key is one shape was kind of sitting like this, and so I give you an answer without the base and one with the base. So maybe if you're just very clear with your math and your labeling, then give me both if you're not sure. Okay. So let's do the volume first. That one, in my opinion, is always the easiest. So total volume, because things are missing here, you're not adding, you're subtracting, right? There's literally a hole through this thing. And so I would go volume of triangular prism, right? Minus volume of square hole. That's what there's not one way of doing it. You just got to be creative with this, but you got to kind of make sure you separate things. At this point, I'd like to say that volume, by definition, is area of the base multiplied by the height of that object. Okay, so if for example, this is a triangular prism, and how do I know that? It has a triangle, and if you were to stack a bunch of triangles on top of each other, you would end up with this shape, right? So that's kind of what the prism is. Okay, so volume of this minus the whole. Let's figure out the volume of the prism. And so I will go area of base times the height. I have to be careful here because there's going to be two heights here. Let me change that to capital H. Capital H height, meaning this height right here. Okay, because there's going to be a height in that triangle as well. So we got to figure out the base here, the triangle. So there's no formula for this to quickly allow you to do it. You can derive one. Where should we do that? I'll just go area of base. I'll do that here. And remember, if we take one of those triangles, right? This one on the top here, we know that it's 8.4 all around. What kind of a triangle is that? We call that an equilateral triangle. And so this will be the base, but we also need the height of it. So area of base would be base times height divided by 2, correct? Because this is a triangle. I need to figure out what the height is along this face here. And maybe you see it, maybe you don't. I will turn this into a right triangle where this is 8.4. Can you see that? 8.4 gets split in half. So this would be 8.4 divided by 2, which is 4.2, right? This side right here, which allows me to find the height. And quite frankly, Pythagorean theorem, it has only two options. If you're trying to find one of the legs, right, we go hypotenuse squared minus this leg here squared. And this is where you want your calculator. You want this one, in my opinion, right? So you go 8.4 squared minus 4.2 squared. That's 5292. So it's root of 5292. If you take that root, second x2, and then copy paste, always use copy paste. That's 7.27. Do not round. So we just write it down like this, indicating that we're using all of the decimals, right? So that's feet. This is very important in our calculation. So we're going to take it back up to what we were doing here. So now that we have the height, let's maybe add some color to this, okay? Now that we have this height, that is this here, which is that height right there. Sometimes it's given, sometimes it's not. But now we have it, so we go back up. What's the base of this triangle? It is 8.4 here. 8.4 times 7.27, and that just keeps going. All of that divided by 2. Let's figure out what this is as just one number. It's just not as messy. Right? So I'm going to go 8.4 base times the height, right? And then divide that by 2. So that's 30.553 and then something. And now we're talking area already. This is square feet. So this number is essentially that one right there, right? I found the area of the base, which is that triangle. And now I can actually do this part. So all of this was like a big side note. I had to derail quite a bit. I had to do all of this to find the height. Then I used it to find the area of the base, which in this case the base is a triangle. Okay. So volume of Prism is that number right there, 30.553, and then some, multiplied by the height. And when I talk this height here, I'm talking the height of that entire prism. So I'm going to go times 29. So I just go back to my calculator, I copy paste this, I go times 29, and I have 886.0479, and that keeps going. What are my units in now? They're actually cubic feet at this point, right? Because if you think about it, this wasn't square feet, and the 29 is just feet. So square feet times feet gives you cubic feet. So either you remember that or just know that when it's volume, it should be in cubic units. So now I found this part, right? That part is now determined. So now I'm going to subtract the square hole that goes through it. So total volume is going to be 886.0479 something minus, how would we do the volume of the hole there? I'll do that here. Volume of the hole would be area of, you can again think of the area of the face of the base, sorry, that'd be 2 times 2. 2 times 2, that's the area of the base times the height, which is 29. you're essentially finding the volume of a box, right? That's what you're finding. That's what, 4 times 29? That's 116, right? So that one was fairly straightforward. So I'm going to take that and subtract it here. So I'm going to go find the 886 minus 116, and there it is, 770.05 cubic feet. Hey, it matches my key. That's always a good thing. So that would be your total volume here that remains, right? So, yeah, different than my key, and I want you to know that as long as you're organized, I'm very okay with that. I'm just going to show my viewers here, my audience, right? I got that from there. And the orange part, I should have probably brought the orange down here as well. And the 29 gets the same color as the big height here. And then you know how everything kind of comes together. So that's the total volume. Now we're going to do surface area. So let's cut this here. When it comes to surface area, maybe another approach, TSA, right? Total surface area. Maybe I've had students do this. They kind of think of everything that needs to be added, and then they subtract what needs to be subtracted. So if you think about it, you can say there are technically two triangles, right? The bottom one here and the top, right? So I'm going to add those two, plus I have three kind of rectangles, like the three sides that are all around the shape, right? So I have those three, so I'm going to add that, plus there are the four small rectangles that go all the way through the shape here, right? Like you can see it better when you look at it this view. There's four longer pieces that go right through. So I have four longer pieces like this. So two triangles. This is the outside. This is the four inside faces. And what else do I need to do here? Subtract the two squares, okay? Because if I add two triangles, it's assuming this is covered up, but they're missing. So I'm going to go minus two squares. So obviously this only means something to me right now because I made it, right? I made this up, but maybe that's what you need to do to know, okay, I need to follow these steps. So let's try that. The two triangles. I'll do that separately. We already have done a lot of work here. So it would be two triangles, which has base times height divided by 2. So that'd be 2 times base, which is 8.4, times the height, right, which is 7.27. So I'll use 7.27 something. All of that divided by 2. Because remember, in here is the formula for area of the one triangle. You have two of them. You can either ignore the fact that there's a 2 here and a 2 there, but I like to use that if I can. So that gives me that. That ends up being 61.106. I'll actually type that in. So watch how I do this. It's very good to, how to use your calculator is very important. So right there. So 8.4 times that. I already did that before, I know that. So that's this number here. Then I'm going to deal with the three rectangles on the outside. I'm going to go out like this, 3 outs. And that is simply going 3 times. Every single face out here is 8.4 by 29. Okay, so you got to go that way. 8.4 times 29, like that. So I'm going to go 3 times 8.4 times 29. That's 730.8. So all of these are going to be added later on. Then you've got the 4 inside rectangles. This is in. Okay. And those measure, there's 4 of them. And each of the pieces measures what? Slow down, Mr. Dirksen. Slow down. I know. What do each of the pieces measure? 2, right? They're 2, and then they're all the way to 29, right? They go in 29 feet. So 2 times 29. You'll get some class time to keep trying this. 232. All of this is what in? This is surface area, right? So it's technically all square feet. Just so you don't forget. I don't care if it's along the way. I don't care what units you like. You don't have to have units as long as your final answer does. So I've done the 2 triangles. I've done the 3 outsides, the 4 insides, and I'm going to subtract the 2 squares. So these are the 2 squares. So there's 2, and each square measures 2 by 2. So this is technically 2 times 2 times 2, which is 8 square feet. And now you just have to state the final answer. I know I'm making it sound like just state the final answer as if it's like a... I know this is not easy. I know there's a lot of stuff involved here. But I'm just going to grab my calculator and copy paste. So it's going to be that number plus the 730 plus the 232 and then minus 8. So there's my total. And I would love it if you find a mistake in my calculations and you tell me. All right? Please tell me if I do make a mistake. First of all, I know you're trying it, so right there, that's a bonus. So I did this one with you. Page 17. How many of you already did 17? I didn't assign 17, did I? I don't think I did. Okay. If you're still writing it down, go for it. So I want you to try some of these on your own. I would love to do whiteboard, but I honestly think that the whiteboards need to be like 3 times bigger to do this properly, in my opinion. So if you like to get up and work on the whiteboards, you feel free to do that. Any one you like, there's a bunch around the room here. So I just want to set it up before you start. So come with me to 17. And if you've done this already, there are going to be other pages for you to try. Partial composite shapes, so halves and quarters and etc. I need you to read this part because I don't want you to try that. Omit the bottom of this piece. So we're going to assume that the floor of this room is not going to be added to the surface area, right? So what it's sitting on, don't worry about it. I just care about the enclosure, okay? Do I just let you once try it and then correct you? I feel like I want to do that. I want you to give this a go. And then I'm quite certain I want to do this with you because this is, I kind of have 3 different types here. And so this is one of them. So give this a try. Give 17 a try. If you did this already, fine. You deserve a little break if you want to do. I'm just going to tell you this. The total volume, if you want to write this down, the total volume is supposed to be 978.28. And the total surface area is supposed to be 408.41. Maybe I'll just say it. I'll just say it. What do you notice about this shape? Do you think of it as is, or can you imagine it as like a full shape, like a full cylinder, like it being mirrored, and then, so this is just half of it, correct? Like this middle part is a cylinder, but it's half a cylinder. This is what, a hemisphere, but it is half a hemisphere. Everything is cut in half. So think about it that way. You can do the halving, to be honest, I always do that at the end. I don't do the halving right away. So I imagine this thing being a whole shape that is mirrored, and then at the very end I will slice my answer in half, and then I have my final there. Okay? So try to give this a try. I will come around and give you a hand if you need a hand. I just want you to, so you can actually see. If you were to start with the back and found the back side and the top circle, this one, all of this, remember that you're technically, if you're not subtracting anything, you're also finding this face already and this face as well already. So with the bottom, you can kind of like knock all of these sections. You can get them all done in one shot by just doing the back one without subtracting anything. Okay. I'll let you do it, and then just look at the key. The key is posted. And I may take some time tomorrow to do this one live, but I want you to try that first, okay? Keep asking me for help if you need, okay? You would want to take away if these formulas accounted for the floor, but they actually never do. When you think about it, right? Like the shape itself never has anything in there. So all of these formulas are omitting the floor as is. If the floor were to be included, you would actually have to add those areas to them. You know what I mean? Good questions. Good question. Your table's probably driving me crazy, eh? I'm gonna fix that later. When they right here? Yeah, I know. Thank you. I'm put them on PPT.
That's right. I have this. Oh, right. So you want to add, right. So I go from end to end. So then I'll let you struggle with it. It's posted anyways. Yeah, I posted it yesterday, but you now saw what issues and you just have to just change that a bit. You could do 20 and 20 as 40 and then have that it's 55, but I'm just going to come from one side, but I was like, did it 30. Oh, okay. So the smallest one is 15. You're starting with the small, you are starting with the small. For the middle, are you doing the middle here? The middle would be what did you say? 35. For the middle, we're going to go 20 and 30 is 50 plus another 20, 70, so half of that is 35. Wait, so the middle will be right. So what would you think you could stack these around one? Very flat and wide. All that kind of half. As long as we don't go with spheres. Oh, maybe I can.
And then for surface area would be no, these are spheres.
Right, these are spheres.
It would be like this, and then two now.
This.
Am I going to still want to
This hit out, this hit out. Yes. I'm just going to double check, but I recognize the 70. I think he's dead. Good work, guys.
I think the L was like that. No, it was like that. It's sideways.
What is one?
You're adding the side.
Do them all separately, that is fine, you just gotta be very careful, because if you, like for example, let's say you start with the back, or let's say you start with the front, but did you do this and the back? Yeah, so that is touching this one, so it's kind of like, can I see that one? So I always start with the biggest, and just find like this whole thing for the big one. Because if you do so, you're finding this, and this already with the back one, and then you just have to add the little piece, like the lateral piece of these. You have to add those yet to the back. Does that make sense? I have those, I use Tinkercad for these, I don't know if you know what that is, it's for 3D printing. So I'm gonna try to, I have them saved, so I'll kind of like spin them for you, sometimes that helps. I think for volume, that works just fine. Yeah, for surface area, I would try to think like, how can I already do a bunch with one, and then I'll just do the other ones I'll add. Right, you don't want to double count. Double count, then you have to subtract, and then it gets. Just this here. Well, keep in mind, anybody, you have a pen there? Keep in mind that this one, so if I were to take this piece, right? And add that piece to it, it's just a flat view of it, right? And then the one that's further back. But if you just take that big one at the back, and use cylinder, right? And you're finding all these spaces already in one shot. And then I'll just add these little side pieces of the smaller ones to it, and then you're done. Right, so I would use the whole on 2 pi r squared plus 2 pi r h for the back one, because that takes care of both. Right? And then here I would just go 2 pi r h, 2 pi r h. And I would obviously at the end to divide everything in half. Yeah. Yeah. Yes. So these types, I'll send you over to from 1 to 24. Sorry, 21 to 24. Yeah. Thursday? Oh, next Wednesday. Is it school related? Oh, yeah, the feeder school. You're doing SMW. Oh, okay. Thanks for letting me know. Is there anybody else in this class affected by that? Yeah. Yeah. Why? Without the base? Like, without the base and with the base, but. Look at that guy. In your radius. If I just add quickly, this is 3,600. 6,500. See you tomorrow, guys. 6,500 plus this should be 25 something. So just fix that. Small, like everything is perfect up to there. That will fix this. And I posted this online yesterday, so check it there. See you guys. Yeah, good work. Good work. Are you graduating this year?
No, I'm gonna
You're just taking it? Okay, smart. Then it's nice and fresh. Are you gonna try challenging other math courses next year or no?
No, I have chemistry and biology.
Next year? Oh, okay, yeah. Smart to do the math now and then you don't have to worry about it. All right. See you tomorrow, Kristen.
Oops, I never pressed pause on the video, so sorry about the big gap there.